This last section in integration by substitution asks us to deal with some definite integrals. So the key change here is that we're going to have to substitute in at the end from 0 to 1 instead of just having our plus c. It's going to require us to first go back to x's before we plug in, because we need to recognize that this 0 and 1 is in terms of x, not in terms of u. So my first steps look exactly like what I would do for an indefinite integral. I start by identifying this as being taken to the 6th power, so it'll be my u, specifically 3x to the 5th plus 8. I'm then going to take the derivative. The derivative of the left side is u, the derivative of the right side. 5 comes down, it gives me 15x to the 4th dx. 8 goes away. I originally just had x to the 4th dx. If I want it to look like 15x to the 4th dx, I'm going to have to multiply the inside by 15, which means the outside has a 1/15. So it becomes 1/15, the integral from 0 to 1 of 3x to the 5th plus 8 to the 6th times 15x to the 4th dx. I can now make my u substitution. It becomes 1/15 the integral of u to the 6th du. There's two different ways to look at these limits of integration. Either I can take this 0 and 1, plug it into this equation for u, and get new limits of integration that are in terms of u. So if I put 0 in here, I'd get 8. If I put 1 in here, I'd get 11. And I could say this is the integral from 8 to 11 of u to the 6th du. Personally, that's not the way that I like to do it. The way that I like to do it is I like to bring in this 0 and 1, have it come back when I'm doing x's and have replaced with x's at the end. So either of the two ways are correct, but really, technically, this should be from 8 to 11 right now if I wanted to leave it in terms of u. When I integrate, the 1/15 stays. It becomes u to the 7th over 7, evaluated from 8 to 11. Again, this would get me to correct answers, but I think it's a little more difficult to see it that way. So instead of doing 8 to 11, I'm going to bring it back to 1/15, 3x to the 5th plus 8 to the 7th over 7, being evaluated from 0 to 1. So again, either of these two methods are correct. Either you can change the limits of integration by plugging what they were in terms of x into my equation for u, or you cannot worry about any of that. Keep the same limits of integration, but just know they don't apply until you put the x's back into the problem. So this really becomes 3x to the 5th plus 8 all to the 7th power divided by 15 times 7, which gives me 105, evaluated from 0 to 1. When I put in a 1, this becomes 1 times 3, which is 3, plus 8, which is 11, to the 7th power, divided by 105. From that, I have to subtract when I put in 0. This becomes 8 to the 7th power, divided by 105. These are huge numbers. That's why I have a calculator. So when I do this in my calculator, I get parentheses 11 to the power of 7 divided by 105 minus 8 to the power of 7 divided by 105 equals 1656 19.2286. I have no idea how many decimal places they want you to go to, but if this said 4, this would be my answer. Obviously, I could round any other number of decimal places, but obviously a ridiculously big answer that you definitely want to use your calculator for here. When I go to do part B, again, it's easy enough to identify what my u is. It's the thing under the root in the bottom. So I start there and say u equals 2x plus 19. My du then is the derivative of this side, which is just 2 dx. I currently have 1 dx if I want to introduce a 2, and I have to put a 1/2 out front. This becomes the integral from 3 to 6 of 2x plus 19 to the negative 1/2 times 2 dx. Now I can replace my u's. It becomes 1/2 the integral of u to the negative 1/2 du. Again, I'm not going to put limits of integration on here because really I should put them in terms of u. But instead of doing that, I'm just going to wait till I turn back to x and go back to the 3 and 6 that I have here. So when I integrate, this becomes 1/2 u used to be to the negative 1/2. When I add 2 over 2 to that, it becomes to the positive 1/2 divided by 1/2 evaluated. This divided by 1/2 becomes times 2 over 1 multiplied by this 1/2 gets rid of it. So I really just have u to the 1/2, or in other words, the root of 2x plus 19 being evaluated from 3 to 6. So again, I didn't have limits of integration here. I didn't have where this was being evaluated because I knew I was headed back to the world of x's eventually. And I decided just to maintain this 3 and 6 instead of plugging 3 and 6 into 2x plus 19 and getting what they were in terms of u. When I plug in the 6, this becomes the root of 6 times 2 is 12, plus 19 is 31. When I plug in 3, this becomes 2 times 3, which is 6, plus 19, which is 25. So I get root 31 minus root 25, which again, I'm going to let my calculator do for me. I know that the root of 25 is 5, but I don't know what the root of 31 is off the top of my head. So when I do this subtraction, my calculator tells me 0.5678 is the correct final answer.